Coming to the first problem, in quadrilateral ACBD, AC is equal to AD and AB bisects angle A. Show that triangle ABC is congruent to triangle ABD, and what can you say about BC and BD? Now moving on to the solution. He has given that AC is equal to AD and he says that AB bisects angle A, that means angle CAB is equal to angle BAD, as given that AB bisects angle A, and if we consider AB is common side for both the triangles ABC and ABD, that is AB is equal to AB common side for both the triangles ABC and ABD. Here if we observe clearly, the side AC corresponds to side AD in the triangle ABD are equal, and angles BAC and angle BAD corresponding to the triangles ABC and ABD are equal, and also AB is common side for both the triangles. Therefore, according to Sas property of congruency, triangle ABC is congruent to triangle ABD. Therefore, if two triangles are congruent, then their corresponding sides and angles will be equal. Therefore, we can say that BC and BD here will be equal to each other. That is, BC is equal to BD. Coming to the first problem, in quadrilateral ACBD, AC is equal to AD and AB bisects angle A. Show that triangle ABC is congruent to triangle ABD, and what can you say about BC and BD? Now moving on to the solution. He has given that AC is equal to AD and he says that AB bisects angle A, that means angle CAB is equal to angle BAD, as given that AB bisects angle A, and if we consider AB is common side for both the triangles ABC and ABD, that is AB is equal to AB common side for both the triangles ABC and ABD. Here if we observe clearly, the side AC corresponds to side AD in the triangle ABD are equal, and angles BAC and angle BAD corresponding to the triangles ABC and ABD are equal, and also AB is common side for both the triangles. Therefore, according to Sas property of congruency, triangle ABC is congruent to triangle ABD. Therefore, if two triangles are congruent, then their corresponding sides and angles will be equal. Therefore, we can say that BC and BD here will be equal to each other. That is, BC is equal to BD. Moving on to second question. ABCD is a quadrilateral in which AD is equal to BC and angle DAB is equal to angle CBA. Then prove that triangle ABD is congruent to triangle BAC, and second thing, BD is equal to AC, and third thing, angle ABD is equal to angle BAC. Now moving on to the solution. In the first case, he asked us to prove triangle ABD and triangle BAC are congruent. Therefore, let us consider the triangles ABD and triangle BAC. In this, he has given already that AD is equal to BC and two angles, that is angle DAB is equal to angle CBA, which is also given. And if we observe clearly, AB is common side for both the triangles ABD and BAC. Now, according to Sas property, triangle ABD will be congruent to triangle BAC, which is our first proof required. Now, we know that when the triangles are congruent, their corresponding sides and the corresponding angles will be equal. Therefore, we can get BD is equal to AC, which is our second proof required. And the corresponding angles, angle ABD and angle BAC will be also equal, which is the third proof required. Now, moving on to the third question. AD and BC are equal perpendiculars to a line segment AB. Show that CD bisects AB. Now, moving on to the solution. He has given that AD and BC are equal perpendiculars. That is, AD is equal to BC as given in the problem. And here also says that they are perpendicular. Therefore, we can write angle OAD is equal to angle OBC is equal to 90 degrees, which is also given. Now, he asked us to prove that CD bisects AB. That means we have to prove that OA is equal to OB. Now, if we consider in triangle BOC and triangle AOD, AD equal to BC, as given that they are equal perpendiculars, angle OAD is equal to angle OBC is equal to 90 degrees. And now, if we consider angle BOC and angle AOD, those will be equal as they are vertically opposite angles about point O. Therefore, angle BOC is equal to angle AOD since they are vertically opposite angles. Now, according to A property, both the triangles, triangle BOC and triangle AOD are congruent. That is, angle BOC is congruent to triangle AOD. The two triangles are congruent, then the corresponding sides and corresponding angles will be equal. Therefore, OA can be equal to OB now. Therefore, we can say that O is midpoint of AB, and finally we can conclude that CD bisects AB at O. Moving on to fourth question. L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is congruent to triangle CDA. Now, moving on to solution. As he asked us to prove the congruency of triangle ABC and triangle CDA, let us consider the triangles triangle ABC and triangle CDA. Now in this, AC is common side for both the triangles. Again, if we consider P is parallel to Q and AC as transversal, angle BAC will be equal to angle ACD as they form the alternate interior angles pair. That is, angle BAC is equal to angle ACD as those form the alternate interior angle pair. Again, if we consider AC as transversal and P is parallel to Q, angle CAD and angle ACB forms another set of alternate interior angles. Angle CAD is equal to angle ACB as they form another set of alternate interior angles which are equal when two parallel lines are cut by a transversal. Therefore, according to ASA property, triangle ABC is congruent to triangle CDA. Now, moving on to fifth question. Line L is the bisector of angle A and B is any point on L. BP and BQ are perpendiculars from B to the arms of angle A. Show that triangle APB is congruent to triangle AQB. And also second thing, BP is equal to BQ or B is equidistant from the arms of A. Now moving on to solution, he says that L is bisector of angle A. That means, given that L is bisector of angle A, that means angle QAB will be equal to angle BAP. Next, he has also given that BQ is perpendicular to AQ and BP is perpendicular to AP. That is, angle BPA will be equal to angle BQA, that is equal to 90 degrees. He has given the statement that BP and BQ are perpendiculars from B to arms of angle A. Again, if we consider AB will be equal to AB in the triangles APB and triangles AQB. Now, according to AS property, triangle APB will be congruent to triangle AQB. We know that when two triangles are congruent, their corresponding sides will be equal. Therefore, we can also say that BP will be equal to BQ. That is, B is equidistant from arms of angle A, or else we can write the statement as B is equidistant from arms of A. Now moving on to the sixth question. In figure 7.21, AC is equal to AE, AB is equal to AD and angle BAD is equal to angle EAC. Show that BC is equal to DE. Now moving on to the solution, AC is equal to AE and AB is equal to AD and also angle BAD is equal to angle EAC. Now, to prove that BC is equal to DE, let us consider the triangle ABC and triangle ADE. In this, AB will be equal to AD, which is given, and also AC is equal to AE, which is also given. And if we consider, he has given that angle BAD is equal to angle EAC. Now to this I am going to add angle DAC on both sides. Angle DAC on both sides, we get angle BAD plus angle DAC is equal to angle BAC, that is equal to angle EAC plus angle DAC will be equal to angle EAD. Now according to SAS property, we can say that triangle ABC is similar to triangle ADE. If two triangles are congruent, the corresponding sides and corresponding angles will be equal. Now in triangle ABC and triangle ADE, we can equate BC and DE as they are the corresponding sides. That is the required proof for us. Moving on to 7th question. AB is a line segment and P is its midpoint. D and E are points on the same side of AB such that angle BAD is equal to angle ABE and angle EPA is equal to angle DPB. Then show that in the first case triangle DAP is congruent to triangle EBP and AD is equal to DE. Now moving on to the solution. As in the first case, he asked us to prove the congruency of two triangles DAP and EPB. Now let us consider triangle DAP and triangle EBP. In this, he has given that P is a midpoint of AB. So we can write as AP is equal to BP. P is midpoint of AB. And we can also say that angle BAD is equal to angle ABE, which is given. And later he also given that angle EPA is equal to angle DPB. Now what I do is I add angle DPE to both the angles, that is angle EPA plus angle DPE is equal to angle DPB plus angle DPE, which implies now angle EPA plus angle DPE will be equal to whole angle APD, that is angle APD is equal to angle DPB plus angle DPE will be equal to angle BPE. Now according to ASA property, triangle DAP is congruent to triangle EBP. When two triangles are congruent, then their corresponding sides will be equal. Therefore we can say that AD is equal to BE Moving on to 8th question. In right triangle ABC, right angle at C, M is the midpoint of hypotenuse AB and C is joined to M and produced to point D such that DM is equal to CM. Point D is joined to point B, then show that in the first question, triangle AMC is congruent to triangle BMD. In the second part, angle DBC is right angled. And in third question, triangle DBC is congruent to triangle ACB. And fourth question, CM is equal to half times AB. Now, moving on to solution, let us note on the given information, that is, he has given a right angle triangle ABC which is right angled at C. So now we can write angle ACB is equal to 90 degrees and he says M is the midpoint of hypotenuse AB. So we can say that AM will be equal to BM as M is the midpoint of AB. And he says D is a point such that DM is equal to CM. Let us note down that DM is equal to CM. In the first question, he asked us to prove the congruency of triangles, triangle AMC and triangle BMD. Now, let us know the similarities in triangle AMC and triangle BMD. Now, considering the figure, if we see triangle AMC and triangle BMD, let us note down the common similarities between them. BM is equal to AM. Since he has given in the question that M is midpoint of hypotenuse AB. And second thing, he has also given that CM is equal to DM. Now, if we consider at point M, angle DMB and angle AMC are both vertically opposite angles. We know that vertically opposite angles are equal, so we can write angle AMC is equal to angle BMD as they are vertically opposite angles. Now, according to side property, triangle AMC is congruent to triangle BMD. Which is our first proof required. In the first part of the proof, we got that triangle AMC is congruent to triangle BMD. Now, if when two triangles are congruent, we can say the corresponding sides and corresponding angles will be equal. Now, if we consider in triangle BMD and triangle AMC, we can say angle DBM and angle MAC will be equal as they are corresponding angles. That is, we can write that angle DBM is equal to angle MAC. Now, if we clearly observe the angles, the two angles are lying alternate interiorly to the lines AC and BD and AB as transversal. So, we can say that line segment AC is parallel to BD. Now, let us prove the second proof. Now, to prove the second one, let us consider that AC is parallel to BD and now BC is transversal. If we consider AC is parallel to BD and BC as transversal, angle ACB and angle DBC become the angles lying on the same side of the transversal. We know that sum of angles lying on the same side of transversal is equal to 180 degrees. We can write angle ACB plus angle DBC is equal to 180 degrees, which implies he has given that angle ACB is equal to 90 degrees, as in the first statement he has given in right triangle ABC, right angle at C. Therefore, angle ACB is 90 degrees plus angle DBC is equal to 180 degrees, which implies angle DBC is equal to, on transposing 90 to right hand side, that becomes 180 degrees minus 90 degrees, which is equal to 90 degrees. So we got angle DBC is equal to 90 degrees, which is our second proof. Now, in order to prove the third proof, that is triangle DBC is congruent to triangle ACB, let us consider both the triangles, triangle DBC and triangle ACB. In this, let us note down the similarities. First of all, BC will be the common base for both the triangles. Second thing, angle DBC is equal to angle ACB, which is equal to 90 degrees. And third thing, if we consider AC will be equal to BD, since in the first proof we have proved that triangle AMC is congruent to triangle BMD, and from that congruency, if we consider that corresponding sides are equal, AC and BD are corresponding sides, so we can write AC will be equal to BD, since from first proof. Now in this, side, angle, side of both the triangles are equal correspondingly, so we can say that triangle ACB is congruent to triangle DBC. So from SAS property, both the triangles, triangle ACB is congruent to triangle DBC. Now we got that triangle DBC is congruent to triangle ACB. Now we know that when two triangles are congruent, then their corresponding sides and corresponding angles will be equal. Therefore, now the corresponding side in ACB, let us consider as AB, then side corresponding to it in triangle DBC will be CD. So now we can equate AB is equal to CD, which implies AB is equal to, now we know that M is the midpoint of CD line segment, so we can write CD as 2 times CM. Now in order to get CM, we need to transpose 2 to left hand side, thereby we get CM is equal to half times AB, which is the required proof